This section is going to be 12.2, and it's going to cover adding and subtracting polynomials. First, before we start, we need to cover some vocabulary. Let me start with monomial. A strange word. Monomial means that you have a number and or variables, and there's multiplication used, and it can have exponents. So it's kind of a long definition. You can look in your book for the definition. You can write it into your notes. I think it'd be easier if I just show you some examples of what a monomial looks like. So an example of a monomial can be a number, like -5 or like 7. It can also be a variable, like a, or like ab, or yes. It can also have variables like a squared b to the 5th. It can have a negative out there with a variable like -m. What that means is -1m, and we'll get to that. What it can't be like, I think this is easier if you talk about a non-example. It can't be like 6 divided by x, or 4 plus m, or a minus b. So it can't have things like subtraction, multiplication, division. It does have, however, multiplication. So if you look at all of these examples, and we look at the operation in there, these are just numbers, -5, 7. A is just a letter, but AB means A times B. So it can have multiplication in it. It can even have numbers and variables with multiplication, like 2am squared. So that's what a monomial looks like. So again, it's a number and or a variable, and it's the product of them. It only has to do with multiplication. The next vocab is degree. Let's talk about a degree of a monomial. If I give you another example of a monomial, like 4x to the 3rd, the degree of that monomial is 3. If I give you like 4x cubed b squared, the degree of that monomial is 5. 5 because a degree is the combination of those, the sum of the exponents. The sum of the exponents. Whoops, exponents. So what about x to the 4th, b, m to the 3rd? The degree of this one is 8. The reason why it's 8, I know that 3 plus 4 is 7, but remember on 12.1 when we talked about there's just an understood 1 right there. If there's no exponent above a variable, then it's understood that that's a 1. And so 4 plus 1 plus 3 is 8. If you have just a number like -2, then the degree of that one is 0. Because there is no variable with an exponent. So the book has a table that looks like this. Here's an example of 4 monomials. And let's talk about what their degree would be. So the degree of -5 is 0 because it does not have a variable. The degree of 6a cubed b is 4 because remember it's a 3 and there's an understood 1 right there where the b is. The degree of -xy is 2 because remember there's an understood 1 on each of those. And the degree of 7y cubed is 3, sorry. If I knew how to edit these videos, I would. Is 3 because of the y cubed. One thing that we haven't talked about yet is what a coefficient is. A lot of vocab in this one, and you might want to make yourself maybe some little vocab cards. You do need to know this vocab. A coefficient is the number that's in there. So if I'm looking at the number -5, then the coefficient is -5. It's just the number. If I'm looking at 6a cubed b, the coefficient is 6. It's a number that's sitting there with the variables, being multiplied times the variables. If I look at the example -xy, there's no number. Let me write it down here for a second. There's no number right here in front. But what's really there is a 1. It's understood that there's that coefficient of 1 right there. I teach middle school and we do kind of silly things. We talk about it being an underwear coefficient because you wear your underwear and it's not supposed to show, and in middle school you always have that problem with saggy pants, and so we say that's an underwear coefficient because it's really there but you don't see it, but it's really a 1. Makes them laugh, makes them remember it. So 7y cubed, 7 is the coefficient. These so far have all been monomials because they only have multiplication between them. And these are called terms. Polynomials was in the title of this section. Whoops. And a polynomial is the category for all of them. So a monomial looks like this, like 2x. A binomial, bi means 2, so a binomial is 2 monomials put together with addition or subtraction. So it might be like 2x plus a. And a trinomial, tri means 3. So that would look something like this, 2x plus a minus 7. So these right here are terms. And polynomials are made up of terms. And the special name for polynomials, there's only a special name for the 3 different types. Monomial, mono meaning 1, so there's 1 term, 2x. Binomial meaning 2, so there's 2x and plus a. Notice that I circled the plus with the a. It's always a sign that's in front of the number. So for example, in the trinomials, I circled the minus with the 7. It doesn't go with the a, it goes with the 7. It's always a sign that's in front. This front one doesn't have a sign, and that automatically means that you're to understand that it's really a positive. So the degree, we talked about the degree of a monomial. What about if you have what if you have a polynomial, something that has more than one thing in it? How do you figure out what the degree is? Like if I start writing this, I start making up 5a. The degree of that monomial is 1 because there's no exponent shown on the a, so it's an understood 1. If I write plus 7b squared, that degree of 7b squared is 2 And if I write 6a squared b to the 5th power, the degree of that one is 7. So if I talked about the degrees, the degree of this one is 1, the degree of this one is 2, and the degree of this one is 7, because remember, it's a sum of the exponents within the monomial itself. So the degree of the whole polynomial is the one that's the highest, the greatest number. So the degree equals 7. So let me give you another example, make sure you understand. So if I have 2x squared minus 4x plus 3 minus 7x to the 5th y. To figure out the degree of the whole polynomial, you have to figure out the degree of each monomial. So I'll put it in a different color. The degree of this one is 2, because x squared. The degree of this one is 1. The degree of this one is 0. Remember, it's 0 if it's just a number. And the degree of this one is 6, because remember there's a 1 up here. So then the degree of the whole thing is 6. So the degree of the polynomial is 6. Identifying properties is the next section. I have 7x squared minus 3x plus 1. Is this a polynomial or is it not? Yes, it's a polynomial. The way I know that is because it has 3 terms and they're separated by add and subtract, and each term has either a number by itself or the product of a number and a variable. So it is a polynomial. Does it have a special name? Yes, it does. This has 3 terms, so it's called a trinomial. And then the book in this example asked you, what is the degree of the entire polynomial? So the degree of this one is 2, because the degree of that monomial is 2, this monomial will be 1, and this monomial will be 0, and the highest is 2. Here's another example. Oops, I don't think I'm going to have room for this. I'm going to go to the next one. 5x cubed minus 3x squared y cubed plus xy squared minus 2y cubed. Same questions. Is it a polynomial? Yes. It doesn't have a special word for it because there's more than 3, but how many terms are there? If I circle the terms, let me change colors here. Here's one term. Notice that I'm hooking that negative with the 3x. That's important for later. I always call this just bubbling the terms. Always the sign in front goes with the term. So if I look at those, there's 4 terms. And the degree of the first term is 3. The degree of the second term is 5 because of the x squared and the y cubed. The degree of the third term is 3 because of the x to the first power y to the second. And the degree of the last term is 3. So the highest one is the degree of the second term. So 2 plus 3 is 5. So the degree is 5. They also had an example that looked like this. It's always good to show one that's not whatever you're learning, so you know what it looks like when it's not. This is not a polynomial. The reason why is because of this division right here. So then we're done with that one. Adding polynomials is the next section. So if we take a couple of monomials, 5x and plus 2r and plus 6x, it's important that you see that there's 3 of those there, and that again, if I circled them, this plus sign right here goes with the 2r, and this one goes with the 6x. Not a big deal when it's addition, huge deal when it's subtraction. So if I look here, I can only add like terms. Oops, that didn't look like. But like terms have the same variable. And this is the really important part too, that kind of tricks people up, is they have to have the same exponent. So you might want to highlight that in your notes. So if I look back at the problem again, the 5x bubble and the 6x bubble are like. I could rewrite this because the commutative property allows me to rewrite, and the book does show you that. You can rewrite it as 5x plus 6x plus 2r and rearrange it. The 5x and the 6x bubble are going to combine together, and 5x plus 6x makes 11x. Notice I didn't say x squared, because if I have 5 apples and I have 6 apples, I now have 11 apples. I don't have 11 apples squared. And so the exponents, that's another reason why they have to be the same. They have to be the same and they stay the same. So last section we dealt with a lot of exponent rules, and so a few of you might want to say, oh, that's x squared. That's only x squared if you're multiplying them. If you're adding them, they're just staying the same because you can only add things with like terms. So I have 11x and I have plus 2r, and that's as far as I can go. That is the answer. That's how you add polynomials. You can only add the ones that are exactly alike. So let's try another example. 4a minus 7a. So I'm going to throw some subtraction in here so you can see why it's important how you group them. And when I've had students that are struggling with the signs, like they say, oh, I have the wrong answer. I didn't understand I was supposed to subtract it. Oh, I don't know when I have to add it. My advice to them is before you even start the problem, make yourself bubble all the terms. For one thing, it will get you to truly understand what a term is. And for another, when you go to look at it and you say, oh, I can put these A's together, you'll put those A's together and you'll put them together with the right signs. So if I take a look at this problem, these 3 bubbles here all have an A. Oh, I wrote this down wrong. Let's change this 7A to a B. I'm sorry. I think I was trying to copy out of the book and I want to make sure I stay the same. Change this to a B. So now that's different. Okay, so the 4a and the minus 20a go together. So in your mind, think about 4a take away 20a. 4 take away 20 is negative 16, so you get negative 16a. See how it can be really easy to miss that minus sign and say, oh, 24a. But you got to make sure that you group that sign with it. There's no other bubble that goes with the minus 7b, so I'm just going to write it down, minus 7b. There's no other bubble that goes with the plus 7, so I'm going to write it down as plus 7. And that becomes my answer. When you go to finish your answer, just make sure that you don't have 2 terms that have the same variable in it. If you do, then you got to put those together. And if there was another number, if there was like a number like 3, let's say that the problem looked like this, we added a 3 to it. Then that 3 and the 7 would go together and make 10. So just plain numbers go together too because they're like terms. Let's see. Then the book has a couple problems with parentheses in it, so we want to talk about that. Probably should have just went to the next page. Sorry about that. If I was to take the parentheses out of this, this would be 3x plus 4. And I'm adding a minus 4x. So if you add a negative, then it's the same as just subtracting 4x. And I'm adding 2. So by taking the parentheses out, I have to think about that each term inside here is being added. If you add a negative, that's the same as just subtracting it. So now I can look at my like terms. Let me circle all my terms first. And I can see that 3x, take away 4x goes together. That makes a negative 1x. Remember, I don't need the 1 there. It's understood if I put minus x, that's negative 1x. And then these two bubbles go together, 4 plus 2, and that makes 6. So that would be my final answer. Try another one out of the textbook. Y squared minus 2y plus 1 plus, 3y squared plus y plus 11. So we could do the same thing. I could take this plus and add each of these terms and take out the parentheses. So y squared minus 2y plus 1 plus 3y plus y plus 11. Now I can look at my like terms. So I can go to my circling strategy. You don't have to do this. Again, it's just a good way if you're not familiar with like terms and if you struggle with negatives. It's a good habit to get into. So y squared, there's no other y squared, so I know that y squared is going to be in the answer. I'm going to go ahead and cross through these as I do them. Okay, this y and this y and this y can all go together. So if I look at negative 2y plus 3y, well, negative 2 plus 3 makes 1, plus another y, because remember there's a 1 right here. So that's going to make 2y. So negative 2y plus 3y makes 1y, and another 1y makes 2y. So I can say plus 2y and cross through that. So negative 2y plus 3y made positive 1y plus another 1y made 2y. And then these two bubbles go together, the plus 1 and the plus 11, to make plus 12. Finished. Notice I can't add the y squared with the y's because they aren't like terms. Your book shows another strategy that you can take it or leave it. It doesn't matter. I don't see this very often. They talk about adding it vertically. I guess there's times when it is useful. But just so you know, there's a different option. You could take the first trinomial part. Oops, I forgot the parentheses just a second. Yeah. You could take the first trinomial, 3x squared minus 3x plus 5. And you could take the second part and line it up, paying attention to like terms. So this would be plus negative x squared plus x minus 6. So if I'm adding this whole thing, all these signs are just going to stay the same. Your book talks about opposites, and you can look in your textbook and you can look at what they call opposites of polynomials. If you're adding, nothing is going to change. If you add a negative, you're going to subtract it. It's when you're subtracting that it gets a little tricky. So now you just add vertically. So 3 plus a negative 1, or you can just think of it as 3 minus 1, is 2x squared. And then let me change colors here so you can see what I'm doing. And then I'm going to add vertically this way. So I did these, and now I'm doing those. So I'm going to add these two monomials, negative 3x plus x. That makes negative 2x. And then the last one makes a negative 1. So you can do it vertically if you choose. Subtracting polynomials gets a little bit more tricky. You just have to be careful with the subtraction sign and distributing it through. You just got to remember again, you can only add and subtract like terms. So if you have 3x minus 4 minus 5x minus or plus 1. This minus right here, you're minusing the 5x and you're minusing the 1. So think of it like distributive property. So I'm going to rewrite it without the parentheses. So I get 3x minus 4. I'm going to subtract the 5x, so minus 5x, and I'm going to subtract the positive 1. When I subtract a positive 1, it's the same as minus 1. Now I can add my like terms. So the 3x and the minus 5x makes a negative 2x. And the minus 4 and a minus 1 makes a minus 5. Minus and negative, you can kind of interchange those. You'll hear me say minus 4, minus 1. You can say negative 4 plus a negative 1. The bubbles, you're adding them together, so if you think about it, negative 4 plus negative 1 equals negative 5. You can also think of it as negative 4 minus 1, because when you do your keep change change, you get negative 5 again. Here's another example, a little bit longer. So remember, you're going to distribute this negative, this minus sign, all the way through. So I'm going to try to write it without the parentheses. 5x squared plus 2x minus 3. Okay, now here's where it becomes tricky. So right here, minus 6x, so x squared, sorry, minus 6x squared, minus negative 7x, minus a negative. Minusing a negative, subtracting a negative, is the same as plain old adding 7x. So taking away a negative is the same as adding it. Might have to think back to those days of the previous math classes. And then the last one is minus, taking away a 9, so it's minus 9. So again, this part right here was the trickiest part. You have to really be careful when you're subtracting polynomials that you're distributing that negative sign. When you distribute the negative sign, notice that, sorry, hold on here. Just notice that all the signs inside of this trinomial flipped because you're subtracting all the way through it. So the 6x squared changed to a minus 6x squared. The minus 7x changed to a plus 7x. The plus 9 changed to a minus 9. That's the hardest part on subtracting polynomials, is getting the hang of distributing that negative. I force myself to draw these silly blue lines. When I teach it in a classroom, I tell them, draw it. You know, you may feel silly at first, but when you draw them, you're less likely to make the mistake because you're going to remember, oh yeah, I've got to change all that. One more example in that section. Oops. Let's see. 6x cubed plus x squared minus negative 3x cubed minus 9. So again, I'm going to write the binomial that they started with. And then again, my negative is distributing through. So taking away a negative 3 is adding 3x cubed. and taking away a negative 9 is adding 9. And then I can combine my 6x cubed and my 3x cubed. Makes 9x cubed. And I don't have anything to combine my x squared to, or my 9. The book also shows this vertically. If you like that vertical method that we did with addition, just look in the book. They do show it vertically, I believe. Or maybe it's another example. It's like the next example, but they show you how to do it. If you prefer to do it vertically, go for it. Then the last part is they made a geometry connection. They said, what if you had this cube? Not a cube, sorry. This three-dimensional figure. The width was x. The length was also x, but the height was y. And they said, write a polynomial reflecting the volume. Well, you know that volume is length times width times height. So I have y times, I'm not going to use a times sign, that's going to get confusing, times x times another x. So how could I simplify that? Think about to last section. If you had x times x, isn't that x squared? So the volume of this container, this 3D container, is y x squared. Or you can say x squared y. It doesn't matter which one goes first. A lot of times the authors will go in alphabetical order. So, and then also at the end of this little diagram, they say what would happen if x was 3 and y was 2. Well, if that's the case, you should be able to find the volume by using your formula. Let me give myself some room here. If x is 3, then that means that this would be 3 squared. And if y was 2, that means that this would be 2. And I could use my new formula. This would be 2 times 9, and it'd be 18. So if they said it was feet, then it'd be feet cubed. All right, so that is the next section. And good luck. Let me know if you have any issues.